Hey everyone, today we're going to discuss about tautology and contradiction. So, when we talk about tautology, this is a statement that is always true. So, the statement, regardless whether the propositions of the statements are true or false, the entire statement would always be true. On the other hand, a contradiction is a statement that is always false. So, regardless whether the statement is, or rather the propositions are true or false, the entire statement would always be false. We can determine whether a statement is a tautology, a contradiction, or neither of the two by using the truth tables. Now, in determining whether a statement is a tautology, a contradiction, or neither of the two, we may need to use the different laws of propositional logic. So there are four laws that we're going to deal with. First is what we call the identity loss. For the identity loss, if we have a statement, a proposition P, and a true statement, it is equivalent to the statement P. Because if P is true, then it's true. While if P is false, then it becomes false, regardless if this is true. If this statement is true at all times. So P and true is always P. So that's basically what the identity laws tell us. It reverts a statement into itself, while P or false would be equal to P. The second one is a domination loss. For the domination loss, it immediately gives us the truth value of the statement, regardless whether the proposition is true or false. Unlike with the identity loss, it depends on whether the proposition is true or false. For the domination loss, regardless whether the proposition is true or false, it automatically gives us what the truth value of the statement. So P or true immediately becomes true, since if true or true, it's true, false or true would also still be true. While for P and false, it would automatically be false, because if it's true and false, it's false, while false and false, still false. So that's for the domination loss. Take note that the results are different. For identity, the result is the proposition, while for the domination, the result is it's either true or false. Now, for the idempotent loss, we are checking what would be the statement if it's combined with itself. P or P is P, while P and P still P. So that's what the idempotent loss tells us. If the proposition is combined with itself with an and or an or, it remains the same. While for the last one, we have what we call the negation loss. So we're going to combine the statement or the proposition with its negation. So P or not P is a true statement. So because this can only be true or false or true, which means that the statement is true. While for the and, P and not P is always false, because this will be true and false or false and true. So these are the four laws that we may need to use to determine the tautologies or contradictions. So let's have an example here. Let's determine if this statement is a tautology, a contradiction, or neither of the two. So we have P implies Q and not Q implies not P. So let's have that kind of example. So let's start off with having the statements P and Q. Let's have the different permutations of this statement. So we have true, true, false, false, or true, false, true, false. So let's start first by having our next statement. So let's have first the P implies Q. So we have P implies Q. So true, true, that is true. True, false, 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 true, true, false, false, true. So this is implies now. So true, false is false. Otherwise, it is true. Now we have the P implies Q. Let's now have the not Q. So that's not Q, not Q. If Q is true, then not Q is false. False, true, true, false, false, true. Let's have the next one here. So for the next one, since we have P implies Q and we have not Q, we can combine them with an and already. So we'll have P implies Q and not Q. So let's have that. Let's adjust so that we can read it properly. So P implies Q and not Q. Let's build that first. So we're gonna look at P, and P implies Q, and we're gonna look at not Q. So we're gonna combine with an AND. True and false. That's false. False and true. False. True and false. False. True and true. That is true. So we have false, 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 true. So let's continue right here. So let's have this. Now that we have P implies Q and not Q, we can have our next statement. So we don't have, before we can have this entire statement, let's have first the not P. So let's fix this first. So this is not P. So not P, if P is true, then not P is false. True, false. If it's false, then it's true. So false, false, true, true. Now we have P implies Q and not Q, and we also have not P. Let's have the entire statement together. So P implies Q and not P implies not P. Again, P implies Q and not Q implies not P. So we're gonna combine this column here with this column here with as a conditional statement. So that is false, false, that is true. False, false, true. False, true, true, and true, true, true. As we can see here, the entire statement would all be true. This means that this statement is a tautology, since all of its statements are true regardless whether the statement is true or false, or rather the propositions are either true or false. It doesn't matter. The entire P implies Q and not Q implies not P. It'll always be true. So it means it's a tautology. If this becomes false, however, then this means that this statement is a contradiction. And if it's a combination of true or false, then it means it's neither of the two. So that's everything for tautologies. For our next video, we're going to discuss about fallacies. So thank you guys for watching. I hope you guys learned a lot, and see you guys on the next video.